today's lesson, we'll see how to evaluate inverse hyperbolic functions using logarithms. That said, let's get into class. Now, we'll be taking this example that says we should evaluate tan inverse of 0.5. Now, we know that if I'm asked to evaluate inverse of the tan inverse of 0.5, it's the same thing as being told that the tanh or hyperbolic tan of x is equals to 0.5. Then what is x? You know that x now will be the same thing as the tan inverse of 0.5. Invariably, what we're actually looking for is x. The first thing I want us to remember is that the hyperbolic tan of x, or the tanh of x as you might call it, is the same thing as e raised to the power of x minus e raised to the power of minus x over e raised to the power of x plus e raised to the power of minus x. Now this is the same thing as, since tan of x is equals to 0.5, this is the same thing as 0.5. Now to reduce this complexity, I want to just represent 0.5 with the letter y. So, or letter z. Let's use the letter z. So that I'll be saying that let 0.5 be the same thing as z. Now, so that invariably we are saying that e raised to power x minus e raised to the power of minus x over e raised to the power of x plus e raised to the power of minus x is the same thing as z. Now let's cross multiply. E raised to the power of z x now minus e raised to the power of minus x will be the same thing as z into e raised to the power of x plus e raised to the power of minus x. Why I've represented with z is just to avoid the complexity of repeating is 0.5 is 0.5 is 0.5. Now e raised to the power of x now minus e raised to the power of minus x will be the same thing as z or z times e raised to the power of x plus z again times e raised to the power of minus x. Now let's collect like terms. I want us to collect like terms by collecting the e raised to the power of x to one side and the e raised to the power of minus x to the other side. It's going to look like this: e raised to the power of x minus z e raised to the power of x equals z e raised to the power of minus x plus e raised to the power of minus x. This is minus x, sorry. This is minus x minus x. So we've collected like terms. So that now I can factorize. E raised to the power of x in the first part, or the right side of the equation, begin to look like 1 minus z equals e raised to the power of minus x into z plus 1. Now, so that here now, I will be saying that e raised to the power of x will be equals to e raised to the power of minus z. You can rewrite this as 1 over e raised to the power of x. Now, this is into z plus 1, 1 plus z. I just want to make it look alike. So this is 1 plus z over 1 minus z. So that they are actually looking alike. Now, if you look at, I have e raised to the power of x. This is 1 over e raised to the power of x. I can multiply both sides by e raised to the power of x here. Multiply this side also by e raised to the power of what? X. So e raised to the power of x will cancel e raised to the power of x. Then e raised to the power of x at this other side becomes e raised to the power of 2x equals 1 plus z over 1 minus z. Let's open another slide. Let's open another slide. Now I've simply rewritten the equation so that e raised to the power of 2x is equals to 1 plus z over 1 minus z. As you know, I'm going to use logarithm to actually finish this equation. What I've been introducing, log to the power of, I've been introducing log to the base of e. So that log to the base of e to both sides, this becomes log e base e, this is raised to power 2x, will be the same thing as log base e. Then we have the whole of 1 plus z over 1 minus z. So that log e base e, obviously we know it is 1. But you know the 2x comes this way. This becomes 2x log e base e equals to log e into 1 plus z over 1 minus z. So that log e base e now obviously is 1. 2x is the same thing as log the base of e is the same thing as writing ln. We write ln, that is 1 plus z over 1 minus z. So that x now becomes 1 over 2, the ln of 1 plus z over 1 minus z. Remember we took an assumption, or remember we took a replacement and we said z is the same thing as 0.5. Now, so that I can conveniently say that my x now is the same thing as half into half ln of 1 plus 0.5 over 1 minus 0.5. So that x now really equals to half the ln of 1 plus 0.5, obviously that's 1.5, over 1 minus 0.5, that's 0.5, which is equals to half ln of 3. Now the ln of 3 from our calculator, this will be half into the ln of 3 from calculator, that is 1.0986, which is half of this obviously is equals to 0.549. The good thing is you can take this as a standard formula to evaluating the inverse hyperbolic function of the tan of x. Thank you for staying with us, and see you in our next class, where we'll be looking at the inverse hyperbolic function of cos and sine. Thank you, and see you in our next class.